College Algebra, Chapter 2, Section 2, Graphs of Equations in two variables. For graphs of equations in one variable, we just need the number line. In two variables, we need the XY plane. We talked about that a little bit before. Let me go through the objectives first, and then we'll go through some examples as we go, because they sort of ask questions in this section that cover both or more than one objective at one time. So, Objective 1. Graphs by plotting points. Now, of course, that really leads back to a XY table. You put in an X, you might start with -3, -2, -1, 0, 1, 2, and 3, so you can figure out the Y value once they give you the equation. Objective 2. Find X and Y intercepts from a graph. Well, my handwriting getting worse. Let's try and make it better. Objective 3 is very similar. It's find the X and Y intercepts from an equation. And the last objective, next page. Objective 4. Test for symmetry. Now we have symmetry with respect to four of them that we're going to be interested in. And this WRT you're going to see means with respect to, first one, the x-axis. And it really means f of x, the function when you plug in a number, equals f of the opposite of x. In other words, plug in a number, plug in its opposite, you get the same y value. F of x is like y. So another way of thinking of that is, if you have this plotted, if you take, I was thinking with respect to the y-axis. Excuse me, let me say this is a negative f of x. I got to take that back. So, symmetry with respect to the x-axis, and maybe this is good because I made that mistake. If this is the point xy, if you have symmetry with respect to the x-axis, not the y-axis, then down below, perpendicular to the x-axis, same distance away, you'll have another point. Now this is still x, but you get a negative y. So since f of x is the same as y, you get a negative f of x. Think of that as plus x there. Symmetry with respect to the y-axis, that's what I was thinking of. And perhaps it's better to draw a graph first. Now if you have the point xy over here, there's a point where you go perpendicular to the y-axis, same distance away, and you get a negative x, but a positive y still. So f of x, you get the same thing when you take f of a negative x. F of x is y. F of a negative x is still y. Third part to this, third symmetry. With respect to the origin. So if we have our picture, if we have the point xy, and we go through the origin, same distance away, same angle, sort of opposite angle, we get negative x, negative y. So this is when f of x equals a negative f of a negative x. Change the y, change the x, change both x and y. And the third one, I'm going to put it over here. I'm sorry, the fourth one, symmetry with respect to a line y equals x. Now this line y equals x divides the first and the third quadrants in half. So if you have a point here and it's xy, then you'll have another point over here, and this is yx. So symmetry with respect to the line y equals x. Now, to do all these, we need to maybe have some equations that we can take a look at. And those equations are what we might call common functions. So these are the common functions, and I'll give you this handout, or you can get this from Dr. Felipe also. These are ones that you should know or eventually know very well. Y equals x squared, so the label for these graphs is the lower left corner here. And if you look at this, what symmetry does it have? Because every point xy has another point negative xy. This has symmetry with respect to the y-axis. Excuse me. So for this y equals x cubed, every point xy, you go through the origin, has the point negative x negative y. That's symmetry with respect to the origin. For the square root, there is no symmetry. For the cube root, every point xy has a point through the origin, negative x negative y, so this is with respect to the origin. Here's symmetry, every point xy has a point negative x negative y, symmetry with respect to the origin. Here's another one, y equals 1 over x squared, that's symmetry with respect to the y-axis. And you notice we won't find any symmetry with respect to the x-axis because they're not then functions. These are common functions. Anyway, that's what you can apply that to for this symmetry. And what about some more stuff here? Let's do a few of the problems on page 171. Let's look at number 16. Now, the directions say, determine which of the given points are on the graph of this equation. So they give you the equation. X squared plus 4y squared equals 4. And the points they want you to check are 0, 1 and 2, 0. And 2, 1/2. So in order to check that, we'll call this, I guess, I and I and I. So for I, we'd plug that in. Put a 0 in for x and a 1 in for y. So does 4 equal 4? Yes, it does. So these, you should have no problems with the 4 steps. Put a 2 in for x and a 0 in for the y. Well, once again, this drops out. 4 does equal 4, so that one works. For I, put in a 2 for x, so it's 2 squared. 4 times 1/2 squared. Does that equal 4? So right away you can say this is 4. This is something bigger than 0, certainly. So there's no way we can add to 4 and get 4. So this is no. And these two, yes and yes. Okay, next one, number 28. Same page. For 28, we're supposed to find the intercepts and graph each equation by plotting points. So that's objective 1 and objective 2. Be sure to label the intercepts. So let's see here. We get 4x squared plus y equals 0. So let's see. We're going to plot some points, I guess, to graph this. So let's try, I guess, now if you're going to try some of these, make sure you put some negatives in here. -2, -1, 0, 1, and 2. Let's try those. In order to do that, sometimes it's just easier to solve for y, isn't it? So I'm going to subtract 4x squared from both sides. And I get y equals a -4x squared. When I plug in a 0 for x, I get 0 for y. When I plug in a -2 for x, I squared, get 4. 4 times a -4 is a -16. Let's go down to this 2. 2's plugged into x squared, you get 4. 4 times a -4, there's another -16 again. How about -1? Squared is +1 times a -4. 1 squared is 1 times a -4. So, but I don't see, are there intercepts for this thing? Here's the x and y axis. Now, the reason I don't label this usually with just single marks until I look this up and say, this is going to be a -16 for the x's are not bad. It's just 1 and 2, and a -1 and a -2. But I need a -16, and just up 0, 0 is one of those points. And maybe I should change, but let me label the axis first. So, if this is a -16, half of that is a -8, and half of that is the -4. So, let me plot some points. 0, 0 is 1. -2, -16. -1, -4. 0, 0. 1, -4. And 2, -16. And then connect the dots. Not too great, but okay. It says, find the intercepts. Well, it's nice to graph it first because then you can see where those intercepts might be. And in this case, the x-intercept is 0, and the y-intercept is also 0. So these are found. Okay. Okay, same page, number 32. We're supposed to plot this point for -2, and then find the symmetry, the point that has symmetry with respect to the x-axis, the y-axis, and the origin. So I is going to be the x-axis, I the y-axis, and I, the origin. So let's first plot this point. For 2. This is the point for 2. So I is symmetry with respect to the x-axis. So it's got to be down here, 2 below. This is the point for negative 2. Remember, this is f of x equals negative f of x. With respect to the y-axis, it should be over here someplace. Negative 4, 2. This is when f of x equals f of negative x. This y and this y are the same for both x and negative x. And the origin. So if we take this point and go through the origin the same distance away, we should wind up at negative 4, negative 2. So f of x equals a negative f of a negative x. So you get 4 steps there too by writing everything down. Let's go on to the next page in your text, 172. Let's look at number 68. You should be able to do most of these graphs, I hope. Number 68. It says, list the intercepts, test for symmetry. So 68 is y equals x squared minus 4 over 2x. Well, before we were looking at graphs for this, but sometimes you just need to plug some stuff in. The x-intercept is when y equals 0. So if we put in a 0 for y, that equals x squared minus 4 over 2x. Now, you can multiply both sides by 2x and you get a 0 here, but you got to be careful because this denominator is in the original, and you know that x cannot be 0, even if y is x cannot be, because that would be here. So you just need to worry about when you multiply by the 2x to make sure you make that note. X squared minus 4, but you can factor that. X plus 2, x minus 2. So here x equals a negative 2, and here x equals positive 2. So this crosses the x-axis at 2 and negative 2, because y is 0. So that's the x-intercept. The y-intercept is when x equals 0. If x equals 0, what is y? Well, let's see. We get 0 squared minus 4 over 2 times... What? We can't let it be 0. There is no y-intercept. Division by 0. Can't let it happen. The symmetry, remember, with respect to the x-axis, does f of x, which is this original, that's the same as f of x, the same as y, does that equal negative f of x? In other words, does x squared minus 4 over 2x equal a negative x squared minus 4 over 2x? Well, that's a problem because you take the opposite of what you get here, and you certainly don't get the same thing. Those two are not equal. So there is no symmetry with respect to the y-axis, or the x-axis. With respect to the y-axis, though, let's see. That's the f of x equals f of negative x. Okay, when we put in an x, we get x squared minus 4 over 2x. When we put in a negative x, we get a negative x squared minus 4 over 2 times a negative x. Now this negative x squared isn't a problem. That's the same as x squared. It's this 2 times negative x that's the problem. So, no symmetry. We should say no here. No with respect to the x-axis. No with respect to the y-axis. How about with respect to the origin? Well, that's when f of x, the x squared minus 4 over 2x, should equal negative f of a negative x. So this is the f of negative x. And if we take the opposite of that, I should be careful here. Negative f of negative x. Well, I can take this negative and apply it to that denominator and leave this numerator sort of alone. Negative x squared is x squared. And if I apply that negative down here, this is 2x. And so, yes. Let's see how this is going to help us graph number 68. That'll help you with some other problems. So, y equals x squared minus 4 over 2x. Now, it's good to plot the x and y intercepts. The x-intercepts are 2 and negative 2. There is no y-intercept, so it'll never cross the y-axis. So it probably approaches it and then goes to infinity or something here. Well, let's plug in some other points. If we plug in for x and figure out what y is, negative 4, negative 3, negative 2 we already know. Negative 1, there is no 0. 1, 2, we already know. 3 and 4. Sometimes it's good to go in these as far as opposites. So if I plug in a 1, I get 1 minus 4 over 2, which is a negative 3 over 2. So 1 is a negative 3 halves. So here's a negative 1, here's a negative 2, negative 3 halves. If I plug in a negative 1, it's still 1 minus 4, but now it's a negative 2. So these negatives cancel, and it's a positive 3 halves. So negative 1 is a positive 3 halves. At 2 and negative 2, it's 0. So it's moving down this way. It never gets to that y-axis. At a negative 3. And at a positive 3. So if I put in a positive 3, get 9 minus 4 over 6. Well, this is 5/6. So the positive 3, I'm at 5/6, almost 1, someplace right here. But at a negative 3, I still get the 9 minus 4, but now it's 2 times a negative 3 or a negative 6. So it's a negative 5, 6, someplace there. One more just to make sure. Add a negative 4 and a positive 4. Oh, I'm sorry. This is a negative 5/6. This is a positive 5/6. And at 4, let's see, 4 squared is 16 minus 4 is 12. 2 times 4 is 8. You reduce this, divide both numerator and denominator by 4, we get 3/2. So with a positive 4, we're at 1.5. At a negative 4, we still get 16 minus 4, but we get a negative 8. So it's a negative 1.5. Now, this may not look like it, but this is going to do something like this, and something like this. So if we take a look at this and say, does this point have a mirror image? Looks like it might. This point, yeah. How about this point? Looks like it's that. And this one? So this has symmetry with respect to the origin. And that's what we had before. Not symmetry with respect to the y, not symmetry with respect to the x. So by plotting some points and noticing the symmetry, we've got a pretty decent graph. We'll do these later on and it'll make even more sense. So you should be able to do the problems. Chapter 2, Section 2. See you in the next section.